Assalamu alaikum, dear cadets. Our today topic is fifth type of equations which are reducible to quadratic form. So come to part 13, question 1, exercise 1.2. So part 8 is x minus 3, x plus 5 into x plus 5, x minus 7 is equal to 385. So look at the equation. There are four factors which are in product form. So the method of this to reduce this equation into quadratic form, the process is combining two factors such that the sum of their constants is equal to the sum of the constant of the next two factors. For example, if we add minus 3 and plus 5, we get 2 plus 2. Similarly, plus 9 and minus 7, we get again 2. So combining these two factors, rearranging, therefore we shall multiply x minus 3x plus 5, and combining these two factors and combining the next two, x plus 9, x minus 7 together, and x plus 9, x minus 7 together. These two, combining the two factors such that the sum of their constant is equal to, the sum of the constant of the first two factors is equal to sum of the constant of the next two factors. Therefore, combining these two by rearranging x minus 3, x plus 5, and next combination x plus 9, x minus 7. So look at these two factors. If we multiply first two, we get x square plus 2x minus 15, and multiplication by the next, that is x square plus 2x minus 63 is equal to 385. So point to be noted here, in the first factor x square plus 2x and the next factor x square plus 2x is common. These first two terms are same. So by substituting the first two like terms, let x square plus 2x is equal to another variable y, r, st, etc. So x square plus 2, let x square plus 2x is equal to y. Then this equation becomes y minus 15 and y minus 63 is equal to 385. Again, simplifying these two factors, multiply it, we get y square minus 78y plus 945, multiplying these two factors and transforming minus 385 to left hand side equal to 0. Thus we get y square minus 78y plus 560 plus 945 minus 385 become plus 560. So this is a quadratic equation in variable y, standard form of quadratic equation. Now we can solve this by either method. So first we solve this by factorization. So by making factor minus 70 minus 8, if we add we get minus 78, if we multiply we get 560. Thus replacing minus 78y by two factors minus 70 and minus 8. Taking y in the first two terms, we get y into y minus 70. Minus 8 in the next two, we get y minus 70. So y minus 70 is common. We get y minus 70, y minus 8 is equal to 0. The product of two factors is equal to 0. So y minus 70, each term, each factor should be equal to 0. Y minus 70 equal to 0 mean y is equal to 70, and y minus 8 equal to 0 mean y is equal to 8. We get two values of y. So by back substitution to get the value of original variable x. So x square plus 2x is equal to y mean x square plus 2x is equal to 70 and next 8, because y is 70 and the second value of y is 8. So by putting y is equal to 70, we get x square plus 2x is equal to 70. Transforming 70 to left hand side, we get 2x square plus 2x minus 70 equal to 0. Thus comparing x square plus 2x minus 70 with standard form of quadratic equation. We get a is equal to 1, quotient of a square b 2, and c the constant term, that is minus 70. By solving this by quadratic formula, putting the values in quadratic formula, we get x is equal to minus b, that is 2, value of b is 2, plus minus b square, 2 square minus 4, value of a into c. Simplifying this one, minus 2 plus minus 2 square become 4, or minus multiplication, positive minus plus, and 4 multiplied by 70, 280. Thus minus 2 plus minus 284 square root divided by 2. 284 square root, we can write 4 multiplied by 71 under root. 4 square root is 2, that is minus 2 plus minus 4 square root is 2, and 78 square root divided by 2. Again 2 is common in the numerator, so 2 is common. We get minus 1 plus minus 71 under root divided by 2. 2 to cancel, so value of x are 2, that is minus 1 plus 71 under root, and minus 1 minus 71 under root. Next, again by putting y is equal to 8, so we get x square plus 2x is equal to 8. Transforming 8 to left hand side, we get a standard form of quadratic equation, x square plus 2x minus 8 is equal to 0. Solving this by factorization, we get 2 factor x plus 4 x minus 2 equal to 0. So either x plus 4 equal to 0 or x minus 2 is equal to 0. X plus 4 equal to 0 means x is equal to minus 4, or x minus 2 is equal to 0 means x is equal to 2. So two values of x, 2 and minus 4. Thus the solution set is 2 minus 4, and the first one 2 values minus 1 plus minus 71 under root. Next is question 2. Solve the equation x4 minus x cube plus minus 2x square plus 2x plus 1 equal to 0. So this is sixth type of equation which is reducible to quadratic form. So the method for, or the process to reduce this equation into quadratic form. The first step should be write this equation into ascending or descending order. So the question is already in descending order, x4, x cube, x square, x and constant term. So next there are 5 terms, so divide the whole equation by the middle term, by the variable of middle term. So here middle term is minus 2x square, so we will divide the whole equation by x square. So dividing both sides by x square, this equation left side total equation divided by x square, and right side 0 divided by x square. From the left side we get x4 divided by x square, we get x square minus 2x cube divided by x square, x cube, x square cancel with x cube, so 1x remains only, so minus 2x, x square cancel, we get minus 2, here x 1 cancel with x, so 2 by x plus 1 by x square equal to 0. So we get an equation in which there are x square term, linear term and constant term. So combining like term mean x square plus 1 over x square plus x like term, so minus 2x plus 2 by x, and minus 2 the last constant term equal to 0. So this become x square plus 1 over x square, taking minus 2 common from this vector. Minus 2 common, we get x minus 1 by x minus 2 is equal to 0. This becomes equation 1. So this equation reduces to type 3 equation. So type 3 equation we have already discussed. So type 3 equation, let substitute the linear term to another variable. So let x minus 1 over x is equal to y to transform this equation into quadratic form. So this becomes, if we take the square, because we need x square, value of x square plus 1 over x square. So let x minus 1 over x is equal to y, taking square of this one to both sides. So left side become x square plus 1 over x square minus 2 is equal to y square. Transforming minus 2 to right side, this become x square plus 1 over x square is equal to y square plus 2. Now put or substitute these two values of x square plus 1 over x square and x minus 1 over x in the equation 1. So putting in equation 1, we get, instead of x square plus 1 over x square, we write y square plus 2, that value, minus x minus 2 into x minus 1 over x value is y, minus 2 is equal to 0. So simplifying the brackets, we get y square plus 2 minus 2y minus 2 equal to 0. Plus 2 minus 2 cancel. We get y square minus 2y is equal to 0. Again, y is common to both the terms. So y common, we get y into y minus 2 is equal to 0. So the product of two factor is equal to 0. Either y is equal to 0 or y minus 2 is equal to 0. So we get two values of y. Y is equal to 0 and y is equal to 2. So, but y is equal to x minus 1 over x, our first substitution. So by back substitution, put the value, first value of y when y is equal to 0. So this become x minus 1 over x is equal to 0. X minus 1 over x, multiply both sides by x. So this become x square minus 1 by x, or by taking LCM, take the LCM x, we get x square minus 1 is equal to 0. Or multiplying both sides by x, the same method. You can simplify by which one is easier to you. So again, now this equation multiply by x to both sides. So by multiplying to left hand side, x cancel. We get x square minus 1 is equal to, on the right 0 into x becomes 0. This means x square in transforming minus 1 to right hand side, x square is equal to 1. Taking square root on both sides, x square root is equal to 1 square root. So x is equal to plus minus 1, that is one value. Again, value of y was 2. So by putting y is equal to 2, this means x minus 1 over x is equal to 2. Again, x is the LCM. So we get x square minus 1 is equal to 2, multiplying both sides by x. So x cancel, we get x square minus 1 is equal to, on the right, 2 multiplied by x become 2x. Or transforming 2x to left hand side, we get standard form of quadratic equation, x square minus 2x minus 1 equal to 0. So solve this equation either by factorization, by any method. So here by quadratic formula, a is equal to 1, coefficient of a square, b minus 2, c minus 1. Putting a, b, c in the quadratic formula and simplifying, we get x is equal to 1 plus minus under root 2. So that is the second solution. So solution set, first x is equal to plus minus 1 and second 1 plus minus under root 2. So the new topic, now come to the new topic, radical equation, exercise 1.3. So what is radical equation? The equation in which the variable appears in one or more than one radicants is called radical equation. Radicand mean any number or any algebraic expression written under the radical sign. So x plus 2, here x plus 2 is radicand and that is radical sign. So any number or any expression written under the radical sign become a radical equation. So or simply we can define radical equation is the equation in which at least one term occurs under the radical sign. For example, x plus 2 under root, that is one term, is equal to 3. So here one radical sign occurs, that is radical equation. Similarly, for example, next x plus 4 under root is equal to 5x minus 1 under root, etc. there may be 3, 4, 5, etc. radical signs. So at least one term should be under the radical sign. So that is called radical equation. So for radical equation, if we solve the equation, for example, which one equation is given. If we solve the equation, at the end we get two values of the variable or solution set. So we will verify these two values of x, either it satisfies the given equation or not. If it satisfies the given equation, that is the solution set. If it does not satisfy the given equation, that is called extraneous root. For example, what is extraneous root? Some solution of radical equation do not satisfy the original radical equation is called an extraneous solution. For example, take example 13. Solve this radical equation. 27 minus 3x under root is equal to x minus 3. So where one radical sign occurs, the method is taking square root. First of all, separate the radical sign to one side. Either it is on left side or on right side. Secondly, taking square on both sides. So by taking square on both sides, 27 minus 3x under root square is equal to x minus 3 square. Expanding the squares, square root cancel with square. We get 27 minus 3x is equal to, on the right hand side, we have the formula a minus b square. A minus b square means a square plus b square minus 2ab. So by expanding that formula, we get this one, x square minus 6x plus 9. Again transforming this to one side, that is to right hand side. So 0 is equal to x square minus 6x plus 9, and this become minus 27, and that become minus 3x become plus 3x. Now by adding the same like terms, x square minus 6 plus minus 6x plus 3x become minus 3x, plus 9 minus 27 become minus 18 is equal to 0, which is a standard form of quadratic equation. Again by factorization, we make two factors of minus 3x, minus 6 and plus 3. So x square minus 6x plus 3x minus 18 equal to 0. In first two terms, x is common, x into x minus 6, plus next two term x3 is common, we get x minus 6 is equal to 0. So x minus 6, x plus 3 equal to 0. So each factor x plus 3 equal to 0 or x minus 6 is equal to 0. This means x is equal to minus 3 or x is equal to 6. We get two values of x. That is the solution set. Now we will verify these two roots. These are two roots of the given equation. Either they are satisfy the equation or not. So to verify the roots for the given equation, put x is equal to minus 3, the first root in the original equation. So by putting x is equal to minus 3 in the original equation, this become 27 minus 3 into x values minus 3 is equal to, on the right side x minus 3 mean minus 3 minus 3. Simplifying, 27 minus 3 multiplied by minus 3 become plus 9 is equal to, on the right hand side, minus 3 minus 3. So on left hand side, 27 plus 9 become 36 under root is equal to, on the right become minus 6. Again 36 square root, positive mean 6, on the right is equal to minus 6. So 6 cannot be equal to minus 6. The result is false. So false result means x is equal to minus 3 is an extraneous root. It does not satisfy the given equation. Therefore that is called extraneous root. And the second root, we verify x is equal to 6. Put x is equal to 6 in the original equation. By putting x is equal to 6, we get 27 minus 3 into x value 6 is equal to, on the right, x minus 3 mean 6 minus 3. So 27 minus 18 under root is equal to 6 minus 3. So this becomes 27 minus 18, 9 under root is equal to 6 minus 3 become 3. Now square root of 9 become 3. 3 is equal to 3. True. We get true result. So if the result is true, this means the root x is equal to 6 satisfy the given equation. Therefore, x is equal to 6 is the solution set. So here x is equal to 6, one root is the solution set, and one root x is equal to minus 3 does not satisfy the equation. So this is called extraneous root. So sometime in the board paper it is given that find only extraneous root. So we have to show this process. So which root we will verify both the roots. Either it satisfies the equation. If it satisfies, that is the solution set. If it does not satisfy, that is the extraneous root. Next, come to exercise 1.3. So in 1.3 exercise, there are three types of radical equation. So first type, this one, in which one radical sign occurs, just like we already discussed example 13. So ax plus b square root is equal to cx plus d. That's a general form. So for example, question 1, part 1, 5x plus 21 under root is equal to x plus 3. Here one radical sign occurs. Therefore, it is first type of radical equation. So the method for first type of radical equation is taking square on both sides. So taking squaring on both sides of the given equation, we get 5x plus 21 under root square is equal to right side x plus 3 square. Expanding, square root cancel with square, we get 5x plus 21 is equal to, on the right hand side, a plus b square. A plus b square means a square plus b square plus 2ab. So that become x square plus 2 into a term into b term plus b square. This become on the right side x square plus 6x plus 9. Now again transforming all the terms to one side, left or right. So we transform here 0 is equal to, transform all these terms to right hand side. We get x square plus 6x plus 9 minus this one, minus 5x minus 21 on the right. So simplifying, adding like terms, we get x square plus 6 minus 5 plus x plus 9 minus 21 become minus 12 equal to 0. Or we can write this in the form x square, this 0 that is extra. So 0 is equal to this equation. Or x square plus x minus 12 equal to 0, which is standard form of quadratic equation. Solving this equation by factorization, we get two factors. Either one factor is equal to 0, either second equal to 0. We get two values, x is equal to 3 and x is equal to minus 4. Two values of x, two roots. Now we check these two roots, either which one of them is solution and which one is extraneous root. So checking the roots, first x is equal to minus 4, and we will check for minus 4 and 3. So for x is equal to minus 4, put x is equal to minus 4 in the original equation. We get 5x plus 21 under root is equal to x plus 3 original equation. So this means 5 into minus 4 plus 21 is equal to, on the right x mean minus 4 plus 3. So on the left side that become minus 20 plus 21 under root is equal to minus 4 plus 3 minus 1. So on the left plus 21 minus 20 become 1 under root is equal to minus 1. 1 under root is equal to 1 positive, and on the right it is negative, but 1 cannot equal to minus 1. The result is false. Therefore x is equal to minus 4 is an extraneous root. It does not satisfy the given equation. Next, for x is equal to 3, put x is equal to 3 in the original equation, 5x plus 21, this one. So by putting x is equal to 3, we get 5 into 3 plus 21 is equal to 3 plus 3, or 15 plus 21 under root is equal to 6. 15 plus 21 mean 36 under root is equal to 6. 6 is equal to 6. The result is true. Therefore, x is equal to 3 or this root satisfy the given equation. Therefore, x is equal to 3 as the solution set. Next, part 4. 2 and 3 is your homework. Very simple. So try it by your own. Part 4. 29 minus 4x under root is equal to 2x plus 3. Again, first type of equation, one radical sign occurs. So the method is squaring on both sides. 29 minus 4x under root square is equal to 2x plus 3 square. So again, simplifying square root cancel, we get 29 minus 4x is equal to, on the right expanding this square by a plus b formula, a plus b square form. So that become a square plus b square plus 2ab, or we get 4x square plus 12x plus 9. Transforming all the terms to right hand side, we get 4x square plus 12x plus 9, and that become plus 4x here, plus 4x and minus 29 here, plus 29, that become minus 29. So 0 is equal to 4x square, and adding 12 plus 4, 16x plus 9 minus 29 become minus 20, or 4x square plus 16x plus minus 20 is equal to 0, quadratic equation. Again, 4 is common to the whole equation. So first of all, taking common, divide the whole equation by 4. We get x square plus 4x minus 5 equal to 0, which is standard form of a quadratic equation. If there is any common in the whole equation, so first of all we will simplify it. We will divide by that term, or taking common and again dividing both sides. So here in this equation 4 was common, therefore we divided this equation by 4. So we get simplified form x square plus 4x minus 5 equal to 0. Again by factorization, make factor of splitting plus 4x into 2 factor, plus 5 minus 1. So we get, if x is common to first two term, we get x plus 5. Minus 1 is common to next two term, we get x plus 5. So we get x plus 5 into x minus 1 equal to 0. Either x plus 5 equal to 0 or x minus 1 equal to 0. So solving these two values, we get x is equal to 1 or x is equal to minus 5. Two roots of the given equation. So for checking these two roots, first of all put x is equal to minus 5 in the original equation, this one. 29 minus 4x is equal to 2x plus 3, that is original equation. Putting x is equal to minus 5 in this equation, that become 29 minus 4 into minus 5 is equal to, on the right, 2 into minus 5 plus 3. Simplifying, 29 and minus 4 multiplied by minus 5 plus 20 is equal to, on the right, 2 into minus 5 minus 10 plus 3. So on the left we get 29 plus 20, 49 square root is equal to minus 10 plus 3 minus 7. 49 square root becomes 7 is equal to minus 7. So, but 7, positive 7 cannot equal to minus 7. False result, therefore x is equal to minus 5 is an extraneous root. Next, for checking x is equal to 1. Put x is equal to 1 in the original equation. 29 minus 4x is equal to 2x plus 3. So putting x is equal to 1, we get 29 minus 4 into 1 is equal to 2 into 1 plus 3. Simplifying this one, 29 minus 4 under root is equal to 2 plus 3, or 29 minus 4, 25 square root is equal to 2 plus 3, 5, or 5 is equal to 5. True result, therefore x is equal to 1 is the solution set. Next, type 2 equations, radical equations. So type 2, look at the equation. X plus a under root, that is general form, plus x plus b under root is equal to x plus c under root. What is the difference between the first and second type? In first type there was only one radical sign. In the second type there are three radical signs, three term linear term under the radical sign. So in such like equation, to reduce them into quadratic form, the method is there are three steps. Step 1, squaring both sides. Step 2, separate the radical term. Step 3, again squaring both sides. For example, part 5, x plus 7 under root plus x plus 2 under root is equal to 6 plus 13 under root. There are three radical signs and the terms are linear. So that is type 2 equations. So in type 2, the first step, squaring both sides. So squaring on both sides. On the left side there are two terms, x plus 7 under root plus x plus 2 under root whole square is equal to, on the right side there is one term, 6x plus 13 under root square. So on the left side, when the square of two terms, when we expanding this, that become the form a plus b whole square. In a square plus b square plus 2ab. So by that method, by that formula, expanding these two terms. First x plus 7 under root square in a square plus second ka square x plus b under root square plus 2ab, 2 into a term x plus 7 under root into b term x plus 2 under root is equal to, on the right side there is only one term, so square root cancel with square, we get only 6 plus 13. Again simplifying, this become square root cancel with square, we get x plus 7 plus this square cancel with square root, we get x plus 2 plus 2 into product of these two terms, x plus 7 under root, x plus 2 under root. So a square plus b square plus 2ab. This term is extra. There is no need of square root. The only this term, first term plus second square plus term 2ab, that is in product form. 2 into x plus 7 under root, x plus 2 under root is equal to this one. Now the second step, separate the radical terms. Mean left the radical term on the right or on the left. So it is already on the left hand side. Transform these linear terms to right hand side and separate this term. So we get by adding these two, x plus x 2x, 7 plus 2 9 plus 2 into this one, 2 into under the radical sign x plus 7 x plus 2. So multiply this one, these two factor, we get x square plus 9x plus 14 is equal to, on the right 6x plus 13. Now transforming these linear term to right hand side, we get 2 into x square plus 9x plus 14 under root is equal to 6x plus 13, and these two terms transform to right hand side, mean minus 2x, that become minus 9. Again simplifying, we get 2 into x square plus 9x plus 14 square root is equal to 6x minus 2x, 4x, 13 minus 9 plus 4. Again 2 is common to the whole equation. So dividing the whole equation by 2 by both sides. So 2 cancel with 2, we get x square plus 9x plus 14 under root is equal to, on the right 4x plus 4 divided by 2 become 2x plus 2. So again the third step, again squaring both sides, applying the third step, again squaring on both sides, that become type 1 equation. So x square plus 9x plus 14 under root square is equal to, on the right 2x plus 2 square. So on the left, square root square cancel, we get x square plus 9x plus 14 is equal to, on the right side by a plus b whole square becomes 4x square plus 2 square plus b square, 4 plus 2ab, 2 into 2, 4, 4 to the 8x. Now 0 is equal to, and transforming these term to right hand side, 0 is equal to 4x square plus 8x plus 4 minus x square minus 9x or plus 14 become minus 14. Simplifying this like term, 0 is equal to 4x square minus x square become 3x square. 8x minus 9x minus 6 plus 4 minus 14 become minus 10. So we get a quadratic equation of the form 3x square minus 6 minus 10 is equal to 0, which is standard form. Now by factorization we can solve this quadratic equation. We get two factors, x minus 2 into 3x plus 5 equal to 0. Either x minus 2 is equal to 0 or 3x plus 5 equal to 0. So we get two values of x is equal to 2 and x is equal to minus 5 by 3. So for x is equal to 2, checking the roots, put x is equal to 2 in the original equation. That become x plus 7 become 2 plus 7 plus 2 plus 2 is equal to, on the right, 6 into 2 plus 13 is equal to 9 plus 4 under root is equal to 12 plus 13. That is 2, 3 plus 2, 5, and 12 plus 13, 25 under root. 25 under root is equal to 5. 5 is equal to 5, true. The result is true. This means x is equal to the first value, x is equal to 2, or this one x is equal to 2. That is the solution set. For the next root, for x is equal to minus 5 by 3, check this root. Put this x is equal to minus 5 by 3 in the original equation. X plus 7 plus x plus 2 under root is equal to 6, 6 plus 13 under root is equal to, next step, minus 5 by 3 plus 7 under root plus, that become minus 5 by 3 plus 2 under root is equal to, on the right hand side, that become 6 into this one, so 3 cancel with 6, 3 to the 6, minus 5 remains plus 13. So it become, here 3 is at the LCM, that become minus 5 plus 21 plus 3 LCM in these two terms, 3 LCM minus 5 plus 6 is equal to, on the right hand side, 2 minus 5 become minus 10 plus 13. So on the left hand side, 21 minus 5 becomes 16 by 3 under root, and this become plus 6 minus 5, 1 by 3 under root is equal to, on the right hand side, minus 10 plus 13, so 16 under root become 4 by under root 3 plus 1 under root become 1 divided by under root 3 is equal to, on the right side, minus 10 plus 13 become under root 3. On the left side again under root 3 as the LCM, this become 4 plus 1 is equal to under root 3. So 4 plus 1, 5 over under root 3 is equal to under root 3. Since 5 over under root 3 cannot equal to under root 3 only, the result is false. Therefore x is equal to minus 3 is an extraneous root. That was the end of today's lecture. See you next with the new topic. Allah Hafiz.